Alright, so let's discuss the question number 1 of 2024 third term test paper of Viasakha Vidyalaya. Right? So here comes question 1 of part 2. We are being given a compound figure made by a semicircle with center O and a parallelogram. Roman 1, find the perimeter. So how do we find the perimeter? We got to add the lengths of all the boundaries. So what are the boundaries of this figure, of this compound figure? Let's start with this semicircle. Let me show the semicircle in orange. So we have to take this semicircle. That's a boundary. And then comes QR. It is a boundary of the compound figure. Then comes QP. Then comes PS. So there are altogether 4 lengths to be added. Let's start with the orange curvy line, or we also call that as an arc or a semicircle. So do we know the length of the semicircle? No, it hasn't been given to us. So first as a step 1, we'll figure out what is the length of the semicircle is, or length of that arc, the orange color arc. So length of the arc So what is the length of the arc? How do we find the length of the arc? What is the formula to find the circumference of a circle? That's 2 pi r. But here we are not looking at a circle. We have a half a circle or an arc. So how do you find the length of an arc then? That is theta over 360 into 2 pi r. So what is theta for this arc? The angle at the center. What is this angle at the center? It's a straight angle. It's 180 degrees. So 180 degrees over 360 times 2 times pi's value. Yes, they haven't said, but normally they would say, they should say to use 22 over 7 as pi. But since it's a term test paper, sometimes they would have missed to say that. So let's use 22 over 7 times the radius. So what is the radius of this semicircle or the arc? We have been told diameter is 42. Here we have been told diameter is 42. So if the diameter is 42, what should be the radius? Half of it, that is 21. So 180 over 360 can be cancelled. 180 has 180 in it and 360 has 2. So some of you would say, since it's a semicircle, instead of writing 180 over 360, we could have directly written half. Why half? Because a semicircle is half of a circle. Yeah, even that's fine. So when you come to a semicircle, you can directly write it as what? Half times 2 pi r. Got it? But see, here I just wrote the general formula to find the length of any arc, that is theta over 360. So then this 2 to this 2 can be cancelled. Then we have 7 and 21 which can get cancelled. 7 has 1 7 and 21 has 3 7s in it. So what are we left with now? 22 times 3. So what is 22 times 3? That is 66. So what is the length of the arc, the orange color arc? It is 66 centimeters. The length of the arc, or the length of, here the arc is a semicircle, so the length of the semicircle is 66 centimeters. Alright, so now let's go on to find the perimeter, but let's do one more check. Do we know the length of the green line? Yes, we have been told the green is 35, QR is 35. So QR is 35. Do we know PQ's length, the top line's length? We have been told diameter of the semicircle is 42. What does that mean? This SR, what I'm coloring in purple, that is 42. Now when it comes to a parallelogram, opposite sides are equal. So if the bottom line is 42, what should be the top line, the line parallel to it? It has to be 42. And what should be the blue line's length? Since the green line is 35, or the green side is 35, definitely the blue side has to be 35. Why? There's a rule which says in a parallelogram, opposite sides are equal. So what is opposite to the 35, green 35? That is the blue one. So blue one should be 35. So now we have all the data that is required to find the perimeter of the compound figure. So perimeter is equal to, now mind you, do we take this purple line into consideration? This purple line into consideration or to our calculation for the perimeter calculation? No, we don't take the purple line to our perimeter calculation. Why not? Because this purple line is not a border. It is not a boundary of the compound figure. So when we are finding the perimeter, we take only the boundaries. Got it? So purple line is not taken into the perimeter calculation. So let's start the perimeter calculation now, starting with the arc, the orange color curvy line, that is 66. We found out as the very first step. So 66 plus 35 plus 42 plus 35. So just a matter of adding these, you can get the answer. 70, 35 and 35 70, and 42 is 112, and 66 178 centimeters. So perimeter is 178 centimeters. All right. All right, let's look at question number Roman 2. Find the length of QO. All right, how do we find the length of QO? How do we find the length of QO? All right, let's see. So how to find the length of QO? Let me put as Roman 2. We have been told semicircle's diameter is 42. Then what is OR? That is 21. And QR is 35. So I guess you would have understood, or you would have got a feeling of using what? Pythagoras theorem. See, look at this orange color triangle. It's a right angle triangle. We know two sides of it. The length of two sides. We know QR's length, we know OR's length, and we are supposed to find QO's length. So whenever we know the lengths of two sides, in a right angle triangle, how to find the third side's length, the missing side's length? Just a matter of applying Pythagoras. So let's apply Pythagoras. Apply the Pythagoras theorem or the relationship to which triangle? To the triangle that I've colored in orange. That is triangle, the right angle triangle OQR. Okay. So what did Pythagoras say? There are two ways to write the Pythagoras theorem. One is, we can say leg 1 squared plus leg 2 squared is equal to the square of the hypotenuse. What are legs of a right angle triangle? Legs are the two sides that is remaining after hypotenuse is taken. So this QR is the hypotenuse. So if QR is the hypotenuse, what are the legs of the two triangle? What are the two legs of the triangle? The right angle triangle. Those are the ones which I'm going to color in blue. That is QO is one leg, and what's the other leg? OR. But most of your schools don't use these terms like legs when it comes to the right angle triangle. Most of your schools would have taught you Pythagoras theorem as a squared plus b squared equals c squared. So up to you. You can write anything. You can write the first one which I wrote, that is leg 1 squared plus leg 2 squared is equal to hypotenuse squared, or else you also can write the Pythagoras theorem as a squared plus b squared equals c squared. Alright, so we have written the Pythagoras theorem. Let's put the equal sign. Always start with the hypotenuse. What does c stands for? The hypotenuse. So what's the hypotenuse of this triangle? Do we know? What is the hypotenuse? Hypotenuse is the side opposite to the right angle. So can you see this square? This is the right angle. So what is the side opposite to it? Side QR. Do we know the QR's length? Yes, we do. That is 35. So in the place of C, what can you write? 35. 35 what? Square. Now comes the two legs. A squared. So what is A squared? We can take QO as A. OR as A. Whatever you want can be taken as A. Let me take QO as A. So do we know the QO's length? No, that is what we are supposed to find. So A will remain as it is, or else what you can do is you can write the length of the name of the side, this broken line, that is QO. So I can write as QO squared. But I don't want to make things complex by writing the name of the side. I'll just write A squared plus. What is B, the other side? That is OR, which is 21. So 21 squared. So what is A squared then? Oh, we'll get the 21 squared. What is 21 squared? That is 441. You can do your multiplication and get the answer. That's 441 equals what is 35 squared? That is 35 times 35. What is 35 times 35? Do the multiplication, vertical multiplication. Then you will get to know it's 1225. All right. Now what's next? Let's go further. So I'm going to take the question to the next page. Let's go to the next page and discuss, or rather continue the question. Right, so how do we find what is a squared? Is a squared equals 1225. We ask the plus 441 to go to other side. What would it become? Minus 441. So a squared is equal to 1225 minus 441. When we do the subtraction, what do we get? We get 4, 8, 7. That is 784. But what we are supposed to find is not a squared. We are supposed to find the length of QO, which is a. So how do we find a now? We'll ask the square to go to other side. So when the square goes other side, what does it become? It becomes square root. Square root of 784. What is square root of 784? There are multiple ways to find this. I'll just show you a method that you have learned in grade 8. That is dividing 784 by prime numbers, or rather you're trying to find, or you're trying to express 784 as a product of its prime factors. How do you do that? That's something you have learned in grade 8. So just recall what we have learned in grade 8. 784 can be divided by 2. That is 392. And divide by 2 once again. That would give us 196. Divide by 2, that would give us 98. Divide by 2, 49. 49 isn't divisible by 2. Then the next prime number, that's 3. But 49 isn't divisible by 3. After 3, 5 is the next one. 5 no, then 7. 49 is divisible by 7. So 49 divided by 7 is 7. And 7 divided by 7 is 1. So what is 784? 784 is equal to 2 to the power 4 times 7 to the power 2. Why 2 to the power 4? See, there are 4 2's that are in the side. So when you multiply 2 to the power 4 by 7 to the power 2, you end up getting 784. Now, what are we supposed to find? We are supposed to find the square root of 784. So we put the square root sign. 784 can be replaced with something equivalent to it. We have found out something that is equivalent to 784. What is it? 2 to the power 4 times 7 to the power 2. So I replace 784 with 2 to the power 4 times 7 to the power 2. So what is square root of 2 to the power 4? What is the job of the square root sign? Square root, what's its job is? Its job is to halve the index. Square root does halve the index. So 2 to the power 4, what will the square root do? It will halve the index. So 4 will become what? What is the half of 4? That's 2. So 2 to the power 2 times, what would the square root sign do to 7 to the power 2? It will make it 7 to the power half of 2. What is half of 2? 1. That is what the square root does. Its job is to halve the index. So we have 2 to the power 2, that is 4. 7 to the power 1, that is 7. 4 times 7, 28. So what is square root of 784? It is 28. But students, this is not the only method to find square root of 784. There are other methods too. And some of you all would say we could have got this answer by guessing. Yes, I'm okay with that too. Like if you can guess, since 784 is ending with 4, the last digit is 4, definitely its square root has to be something ending with 2 or something ending with 8. And since 784 is between it's between 400 and 1000, or between 400 and 900. Now 20 squared is 400. 30 squared is 900. Now where is 784? In between 400 and 900. So definitely the first digit of square root of 784 has to be something with 2. It has to be 20 something. Since the last digit of the number is 4, definitely the square root has to be ending with 2 or else 8. But it can't be ending with 2. Why am I saying so? Because 784 is very close to 900. So the square root of 784 cannot be 22. Less chance, no? So if 22 is a less possibility, it has to be 28. So in that way too, you can get the answer. Got it? Makes sense? Alright students, so I hope you all understood. Alright. So we found the length of QO using Pythagoras theorem, right? So we got to know QO is 28. Let's look at Roman 3 now. What is Roman 3? We have been asked to find the area of parallelogram PQRS. So how do we find the area of a parallelogram? What is the formula? Yes, try to recall the formula to find the area of a parallelogram. What is area of a parallelogram equal to? Yep, that is base into height. So Roman 3, area of PQRS, parallelogram PQRS is equal to base into height. So what do we take as the base where the 90-degree line is standing on? That is standing on SR. What is SR's length? SR is the diameter, which is 42. So 42 times the height of the parallelogram, or the perpendicular height between SR and PQ. What is it? That's QO. While ago we found out that it's 28. So 42 times 28. Just a matter of multiplying, you end up getting the area of the parallelogram. 42 times 28. When we do the multiplication, that is 1176 square centimeters. Area, the units of area should be square centimeters or square meters, depending on what they have given. Here it's centimeters, so it should be square centimeters. Alright. Roman 4, find the area of the semicircle. Oh, quite easy. So how do we find the area of a semicircle? First we got to write the formula. Question 4, area of the semicircle. How do we find the area of a circle? Pi r squared. Pi r squared is what we use to find the area of a circle. But since it's a semicircle, it should be half of pi r squared. So half of pi r squared. So that's half into what is pi? We use 22 over 7. What is the radius of the circle or rather semicircle? That's 21. So r squared means r times r, which is 21 times 21. So there's an opportunity, there's a chance of cancelling. So cancel. 7 has 1 7, 21 has 3, 2 has 1 2, and 22 has 11 2's. So what are we left with? 11 times 3 times 21. 11 times 3 is 33. 33 times 21, what is it? That is 693 square centimeters. So for this, the answer is for Roman 4, the answer is 693 square centimeters. What was the area of the parallelogram? We found out that to be while ago we found out. Let's write that also. That is 1176. Find the area of the compound plane figure. Quite easy. The compound figure is consisting of two shapes. What are the two shapes? At the top there is a parallelogram. Its area is 1176. And below the parallelogram, what has been fixed? A semicircle has been fixed, which has an area of 693. So what's the total area of the compound figure then? Just a matter of adding the two areas. So we would end up with 9. 7 and 9 is 8, 16. 1 remains 8. So when we add, we get 1869 square centimeters. Alright, that's it with question 1 of part 2 paper.